Okay, let's look at some of the properties of definite integrals, and some of these are going to kind of remind you of the properties of derivatives a little bit. So let's take a look at the first one here. We have the order of integration, and this one's a pretty unique one, and pretty common that they tested on. But it basically says that if you have the integral and you're going from b to a, where b is the lower limit and a is the upper limit. So remember graphically what that looks like. If you have some integral maybe that looks like this, and here is a, the lower limit, and b is the upper limit. If you integrate, actually I did that one backwards, didn't I? I don't like the way they define that, but let's correct that. B is the lower limit here, and A is the upper limit, according to this definition they gave us. If you integrate from B to A, it's the opposite of integrating from A to B. So if you switch the order of integration, the natural order is to put the smaller number on the bottom, and then the larger number on top. And this just basically says if you switch that order, then the definite integral just becomes the opposite. So if you had a positive, it ends up being a negative. If you had a negative, it ends up being a positive. So we'll take a look at one like that in our homework, I'm sure. And the next one is the zero property, and basically it says if you take the integral and you evaluate it without going anywhere from a to a, it's just equal to 0. There's certainly no area that you can develop if you don't have any horizontal distance there. And then the next one is the constant. The constant multiple basically just says that if you have a function multiplied by some constant, you can pull that constant out, take the definite integral, and then multiply that answer by k. And then the second portion here shows that if you had a negative sign out in front of there, -1 say, you could pull that negative out and just multiply the answer by -1 when you're finished. The sum and the difference, if you have two separate functions and you're adding them together or subtracting them, you can take these separate integrals at the same values, same upper and lower limits here, and just evaluate them into two separate integrals if that's easier. And then the second one is a little bit different, but it kind of makes sense. This is saying that you have some function and you're going from, say, A to B. So you're going from here, this A, to say this B, and then you're going to add to it going from B to C. In other words, if you split this up into two parts and you evaluate this one first, and then say you do this pink one over here from B to C second, it's the same thing as evaluating it over the entire interval from A to C. Okay, so let's take a look at these properties and look at a problem here that's out of our textbook here. So the first one says, if you have a function that's continuous and you know that from 0 to 3, 0 to 3 is equal to 3, and from 0 to 4 it's equal to 7, could you evaluate from 3 to 4? So if we look at the additive property, it's hard to say, it says that the entire length would be from where? Whoops. From 0 to 4. So if I can get a pen here. So if we're going from 0 to 4, and 0 to 4 of the function is equal to the summation, or the adding from 0 to 3, plus going from where? from 3 to 4, right? And notice in part A, they're asking us to find 3 to 4, right? So this just becomes sort of an algebra problem. You don't really have to do any calculus on this. If this part from 0 to 4 is equal to 7, and from 0 to 3 they've defined that it's equal to 3, so the integral from 3 to 4 of the function is just simply 7 minus 3. So it's not too bad. So if I get some more space here. So this would just be 4 is equal to the integral from 3 to 4 of the function. Okay? Part B, well, we just found from 3 to 4 in part A, right? And this one, in B, they're just simply reversing the integration limits from going from 3 to 4, from 4 to 3. So these we're going to go back and look at the first property, which says the order of integration, if you switch them, then the answer is just the opposite. So in part B, the integral from 4 to 3, which is backwards, is simply going to equal, it's equal to the opposite of from 3 to 4. And since we found 3 to 4 in part A, the answer to this is just a -4. Alright, so once you get a little practice with these properties, they'll become second nature to you.